Good evening and welcome to this presentation. In this session, I'll be explaining the implementation of the dimensional model in the data warehouse. In this presentation, I would like to first of all give the objectives for this session. So I'll explain the 4 steps in dimensional design process plan, explain the basic fact tables, uh, how basic fact tables can be handled, discuss the inside of OLAP Cube and other alternatives. I'll explain dimension designs and applicable components. I'll move forward to describe the various enterprise dimension model schemas, the enterprise dimension management schemas commonly used, and then compare between star schema and snowflake schema, and I'll wrap up with a summary of the presentation. So to start with, in order to effectively design a dimensional process plan, we need to pay attention to the key 4 steps of a dimensional design process. This selecting, the very first step is to select the business process. Actually, a business process is a low-level activity performed by an organization, such as taking invoices, receiving payments, handling service calls. There are some key characteristics that must be considered while selecting a business process, and some of these characteristics includes taking cognizance of the fact that a business processes are frequently expressed as action verbs. They are typically supported by an operational system such as the billing or purchasing system. They are they generate or capture key performance metrics. The next thing I want to look at after selecting a business process is to declare the grain. Yeah, what I mean is you should be able to specify exactly what an individual fact table or row represents. The grain conveys the level of details associated with the fact table measurement. I go further to explain that the grain is, represented by the physical realities of the operational system that captures the business processes events. Now, having declared the grain, it's very important to identify the dimensions. So, the dimensions here actually refers to all the dimensions are used to provide details to measures or facts. A careful identification of the dimension table will give more meaning to the grain earlier declared in the process. In order to complete the identification of the dimension process, it's good to look at the various questions that are raised. The who, what, where, when, and how. The who stands for the customer. What customer are we selling to? What is what product are we selling to the customer? When, what time are we selling this product to the customer? Where is the location where the customer is being sold the product, and at what time the product is being sold to the customer? The how is this product being sold? Is it through promotion, coupons? And so if you look at the diagram on the left, it talks about identification of dimensions. So there you can see what I'm talking about. After this, the next thing is to identify the facts. If the dimensions are well identified, then the fact automatically is determined. The fact here is aimed at measuring the values. What are we measuring? Quantities sold. We are measuring sales and other numerical values. So the next thing we want to look at is the insight into OLAP Cube. Insight into OLAP Cube and other alternatives. In order to do this, we have to define what an OLAP cube is and then look at subtypes of OLAP cube. So actually, OLAP stands for Online Analytical Transaction Processing. OLAP cube is, it has a cube actually has 3 different types. We have ROLAP, MOLAP, and HOLAP. Actually, the HOLAP, combines MOLAP and whole roll up together in order to perform its transactions. The next thing that the next key thing I want to look at is the parts, key component parts of a multi-dimensional model. You have the data source view, dimensions, and cubes. The data source typically is the source where the data is being taken from into being brought into the data model. The data source view actually is where the fact table is being determined. The fact and dimension tables are being determined to be used. The dimensions actually helps to the dimension is used to categorize the dimensions into hierarchies. For example, dates can be categorized into years, quarters, month, and semesters. And the cube actually is the cube is used to process the data, and then the cube is used to it can be used to process the data and then deployed into the database. Now we have to look at the different types of enterprise data management schema. So we have star schema and snowflake schema. The snowflake schema is a relational database. It contains measures and facts. It has the fact is found in the center of the model or the scheme. Now the fact table has foreign keys that relate to the different dimension tables at the lowest level of the hierarchies. For this snowflakes is actually it also has a fact table in the center of it and relates to the different dimensional tables through the foreign keys that points to the lowest level of the highest of the hierarchies for each dimension tables. But the thing is, with snowflakes, the dimensions are broken down into sub dimension tables. We'll go further to look at the differences between a snowflakes and a star schema. A snowflake actually a star schema, sorry, has in a star schema hierarchies are stored in single dimension tables, whereas in snowflakes hierarchies are stored in multiple dimension tables. In star schema data structure is denormalized, whereas in snowflakes data structure is normalized. In a star schema queries runs faster, and in snowflakes queries run slower because of the numerous dimension tables. Now, for summarily, we have a multi-dimensional database is structured around measures, dimensions, hierarchies, cubes, and other tables. We have summarily, we have 4 steps of dimension designs that are supposed to be taken into consideration when implementing a multi-dimensional model in a data warehouse. So I want to thank you for attending this presentation, and I hope to see you in my next video.